All right, for my next problem, exercise 1. Spraying plants with cornmeal juice is a natural way to prevent fungal growth on plants. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table by answering the questions that follow. All right, so first we're gonna go ahead and write out our ratio table. So, and then we'll look at some of the questions. So, cups of cornmeal, 2 gallons of water. And again, this is a 2:9 ratio, and I wanna make sure it matches. 2 corresponds with cornmeal, 9 is with water, so cornmeal to water, okay? I can't simplify this anymore, because 9 is not divisible by 2. So I'm gonna start with that 2 and 9. So for every 2 cups of cornmeal, you will need 9 gallons of water. So if I add 2 more cups of cornmeal, that will be 4, and then 9 more gallons of water will be 18. Okay, so after 4, I'm gonna add 2 more cups of cornmeal. I will get 6. Add 9 more gallons of water, and I will get 27. Again, 2 more cups of cornmeal, 8. 9 more gallons of water, 36. 2 more cups of cornmeal will give me 10. 9 more gallons of water will give me 45. Okay, so for every time we added 2 cups of cornmeal, we have to also add 9 gallons of water to keep that ratio consistent. So now letter A says, how many cups of cornmeal should be added to 45 gallons of water? Well, I see on my table, if I have 45 gallons of water, I'm going to want to add 10 cups of cornmeal. For letter B, it says Paul has only 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? So looking back at my ratio table, looking back at my ratio table, I can look for 8 cups of cornmeal, and I see that he can add 36 gallons of water to make the most amount of cornmeal, or else it's gonna be too watered down, it won't work. So for that ratio, for a good batch of that cornmeal juice, he needs to stick with the same ratio, so 8 cups of cornmeal to 36 gallons of water. And then for C, what can you say about the values of ratios in the table? Well, let's look at the values of the ratios. I have an idea, I have a prediction from what we talked about in the first example, where I feel like I know that the value is going to be the same, right? And that's something that we talked about in our content goal as well. If 2 ratios are equivalent, then they have the same value. So let's just take a look here. I added an extra little column to my table. 2/9, that is reduced as far as it will go. 4/18, what can I divide those both by to reduce it? Well, I know they're both even numbers. I can divide them by 2. 2/9, yep. So far, it's matching up our pattern. Looks like these are equivalent. 6/27, I could divide both sides by 3. And I'm gonna get 2/9. 8/36, I can divide both sides by 4. And I'm gonna get 2/9. And finally, 10/45, I can divide both sides by 5. And I get 2/9. Okay, so back to the question, what can you say about the values of ratios in the table? Well, what can we say? Are they the same? Yes, they're the same. And what is the value of all of them? 2/9. So all of the ratios in our ratio table have the same value, which is 2 over 9. Oops, forgot the word is. There we go, which is 2 over 9. All right, guys, and this is our last exercise, exercise 2. And now some of you might be sitting there going, Miss Rotondella, I get it. Because this is a little bit of a, we can see the pattern, so we can fill out the table, but I really want to reiterate, like I said it was coming, that it might be tempting to just plug the numbers in. You have to pay attention to the label and make sure that the numbers in your column match with that label. So let me explain that by reading this problem. James is setting up a fish tank. He is buying a breed of goldfish that typically grows to be 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water per fully grown goldfish in the tank? Okay, complete the ratio table to answer the following questions. So before you just start filling numbers out, we have to think about what this is asking. Okay, because there's a step before we can just plug numbers in. So for the number of fish to gallons of water, let's look back at the problem. It says his breed of goldfish, so every goldfish that he has can grow up to be 12 inches long. Okay, so that's just one goldfish being 12 inches long. It's recommended that there be 1 gallon of water for every inch of fish. So if this fish is full grown, it's 12 inches. Okay, so for 1 gallon per inch, a 12-inch fish would need how many gallons? Not 1 gallon, it would need 12 gallons. 1 gallon for every inch. So 12 gallons for every 12-inch fish. Okay, so going back to our chart, now we're ready. Number of fish. So if he has just 1 fish, and he has how many gallons of water? 12 gallons. Now we can go from there at that 1 to 12 ratio. So we add another fish, that's 2. That's another 12 gallons of water, so 24. Add another fish, that's 3. That's another 12 gallons of water. So 36. 4 fish would need 48 gallons of water. And 5 fish would need 60 gallons of water. Okay, and that's our question here. What size tank in gallons is needed for James to have 5 fully grown fish? So if he wants to have 5 fish, he needs a big 60-gallon tank. So a 60-gallon tank is needed. Okay, let's look at B and C. All right, so for B, it asks how many fully grown goldfish can go in a 40-gallon tank. So if we look back at our chart, we don't have 40 gallons here, but we know that 3 fish can fit, they need a 36-gallon tank. 4 fish, they need 48. That's so 4 fish would not fit in a 40-gallon tank of water, so he can only get 3 fish. Even though they only need 36 gallons, he's got a little more. He doesn't have enough for that 4 fish because they need 48 gallons. So he can, what was his name? James can have up to 3 fully grown fish. Okay, and he can have 2 or 1, but he can have up to 3. And then what do you say about the values of the ratios in the table? Well, we know that they're all going to be the same, but just because we're really great at our math jobs here, we're not only going to assume that, we're going to prove it. So right now, I'd like you to pause your video and find the values of each one. I will do the same, and then let's just double check our work together. Okay guys, so when I went through and did it, I noticed that I did get 1/12 for each one. Now, you're not just doing this for like extra unneeded work. This is really important for you to check your value, your ratio table, because if you're doing this and you come up with a different value, that's where you can find a mistake. You can say, oh, I did the math wrong. I put a wrong number here. And great mathematicians, they always double check their work. You just want to make sure all the puzzle pieces fit correctly to know and be really confident that you have the right answer. So I did get 1/12 for each of the values. So what I can say about each of the values is that each ratio had the same value, which was, sorry, that's a really sloppy comma. I'm trying to write fast, which was 1/12. All right, guys, that wraps us up. Quick lesson summary. A ratio table is a table of pairs of numbers that form equivalent ratios. And when you guys are working on your problem set today, it's going to ask you to not only complete the tables, but also choose one of these tables. So I could choose this one or this one or this one, and create a real world context of the ratios shown in the table. So figure out what is the ratio, what is the original ratio being shown here that all of these are equivalent to, and kind of give a real world example of that ratio. So that would be like any of the examples here, like the problem talking about James and his fish tank. Okay, so you're setting up your own real world context for just one of these tables. All right, guys, awesome job. I will see you to check your work.